Good evening, everyone. Hope you are all doing well. This is the fifth session of the AI series. We will be starting now. Please make sure you have opened your Google Colab links. If you have not already, I will be sharing them in the chats in a few moments. Doctor, are we ready to start?
Yes, Elisa.
Okay, go ahead.
So you're welcome to this fifth and most probably the last session of our machine learning and artificial intelligence workshop. In this session, we are going to have some applications. We are going to talk about TensorFlow, some basic concepts. Keras, what is Keras? We are going to see an application that uses TensorFlow and Keras. I'm going to also introduce Tensorboard. We're going to check the examples on colab, the examples on the TensorFlow and Keras, and the example on the Tensorboard. So to begin with, I'm going to explain about TensorFlow. By definition, it is Google's second generation software library. So it is a library that has, as any other libraries, a lot of programs. Practically, it has programs, what we call data flow programming. Data flow, it means we have steps one after the other, and this is how we are going to program the machine learning protocols. So TensorFlow supports various deep learning algorithms, and this is the key that makes us use Python itself, because when we use Python, we have libraries like TensorFlow, and inside TensorFlow, we have a lot of deep learning algorithms. It means that whatever we explained in the neural networks chapter, we are not going to go program all the details. We are only going to take the concepts, and we are going to use the TensorFlow library in order to create our protocol and use it. And we have an additional information, additional use. We have TensorFlow has a GPU version. It means that if I have a computer with a GPU, that's a graphical processing unit. GPU makes the programming and the learning of machine learning algorithms much faster, but it needs an internal program to do that. It's called the CUDA program. TensorFlow GPU, once you download it and install it on your computer, it has CUDA implemented internally, so you don't need to program CUDA in order to use your GPU. This is where we have an advantage in TensorFlow, but this is you only download it whenever you have a computer with a GPU. In TensorFlow, we are going to hear some keywords. We're going to hear about the tensor. So the tensor actually is the data in the form of a tensor. We're going to hear about the graphs, nodes, and edges, because the data flows inside the TensorFlow and nodes, and the edges are the links between them. We have several operators, and the TensorFlow executes inside the session. So inside this session, we have the feed and the fetch of the data. This means we are going to feed it information, and we're going to have its inputs and outputs in TensorFlow. And we have actually the variables. What about Keras? Keras is what we call a machine learning API. An API is an application programming interface. I'm just going to jump into simply said, it is a library. But Keras library is going to use what we call a backend. So Keras library doesn't have all the information, doesn't have all the programs that TensorFlow has. It is only a library that works on top of TensorFlow, so it uses the functions that are programmed within TensorFlow in order to create a procedure. So it uses them in order to build up the machine learning algorithm. I'm going to try to explain it better inside the example. So in here we have an example. It's from TensorFlow website. It's the beginner example. So it is a basic machine learning algorithm. And here we always begin by importing our libraries. So we import TensorFlow. When you say import TensorFlow STF, this is the abbreviation because we are going to use it later on all the time. This is why we try to abbreviate the name. So we are going to load the MNIST dataset. The MNIST is a set that is very classically used in machine learning. It is a set of handwritten numbers. So it's already in here in Keras. So if you see MNIST is the name of the variable of the dataset that we are going to use. It's TensorFlow.Keras. So in here they have the Keras library. Within Keras, I have datasets and I have the MNIST. This means when you download Keras, you already have this library inside. So this is part of what Keras can provide for us in machine learning. So it provides sample data sets that we can use in our training to train our, or try some examples and train our machines. So in here I'm loading from the MNIST, the X train, Y train, X test, and Y test. To begin with, I have divided my data, or the data provided by this library are already divided into two parts, training and testing. If you remember what we said before, we also had a validation part that does not exist in here. And we have the X and Y. X and Y, this means I have the image and I have the reference. So if the image is corresponding to a digit number 7, Y is 7 itself. So Y is a one digit where X is the image. So we begin by taking the images, X train and X test, and normalizing them. Why 255? Because the colors, the variation of colors, and it is a black and white image, so it's grayscaled, and when it's between 0 and 255. So when you divide by 255, the values become between 0 and 1. And we normalize them because the model is going to learn them easier when they are normalized. Then we are going to build the model. Up until here, there has been no execution of anything. We are just building our model. We are just preparing our machine. This is our machine. So when we talk about machine learning, this is our machine. So the model that we have, it's from Keras models. It is the sequential model. Sequential, this means one after the other. So the first layer, I have the flattened layer. The input shape is 28 by 28 because the images that I have are 28 by 28 pixels. So I define the input data that I have. Flatten is going to take my image from a square, 28 by 28, to a full line. So it's going to align them in one line so that I can give them as an input to a neural network. On the second layer, it's a dense layer, and a dense layer is a neural network itself, is a fully connected neural network, the one we defined at the beginning of the machine learning chapter. It has an output of 128 neurons, and it has the activation function ReLU. You can change it, you can choose another activation function, but this one is a classically used one. Dropout is a function that we usually use in order to reduce overfitting. Overfitting is when the machine memorizes the training data and fails in the test. So we have a dropout of 20% in here, 0.2, that's 20%. And we have a final layer, a second layer. So our machine is made of 2 layers of dense with output of 10, because we have to classify digits between 0 and 9. Therefore, we have 10 different classes at the output. So after defining our model, here we have in the application, we are going to see it in the colab, we have the predictions. We take just one from Xtreme, just choose one example, and we are going to see the predictions. This means if I take the first example, before the machine begins learning, before it develops its weights to recognize these digits, at the first example, it is not going to recognize it. So you are going to see it going to give a probability of almost 10% to any of the different digits. It means that if I have, if you all know probability, so if I have something that I'm tossing a dice, but a dice with 10 faces in this case, the probability of having just anyone is 10%. So the probability of just choosing arbitrarily a digit between 0 and 9, you could choose any digit with a probability of 10%. So if it gives you this kind of probability, or if you are classifying between 2 different classes and it gives you the probability of 50%, that's nothing. It hasn't learned anything, because that's by nature itself, it didn't learn yet. So in here, we are going to check if it is going to give us around 10% for each of the possible outcomes. And there we have another function. This is the loss function. The loss function is a function that's going to calculate out of these probabilities a value. This value tends to 0 if the predictions are correct. And the value is greater, in this case, going to be around 2.5 or 2.3 for values that are incorrect. So the smaller the value is, the smaller the loss is, the better the prediction is. So we are going also to check our loss function for our first value, for our first training value. And here we see a loss function with inputs y train 1. So this is the real outcome, the real output, the real value itself. And the second input is our prediction. Then we are going to compile the model. This means we are going to build it up. In here, this is the learning. So when I call the model, I say model fit, I give it the inputs, X train and Y train. In here, they have chosen 5 epochs. This means that we are going to provide all the data that we have 5 times to the model. This means we have, let's say we have 100 values. We're going to give these 100 values to the model 5 consecutive times, and at the end of each time, check if the model has learned correctly or not. If you see that when you are testing, if you see that your model hasn't learned enough, you can increase the number of epochs. If you see that number of epochs is too much and your model has already learned correctly, you can reduce it afterwards. The evaluation is going to be on the test values. This means if I check that my model has learned, I want to see that if I give it new set of data, it is going to discover what they are. It's going to recognize them correctly. So this is the testing. And here we just passed to the Tensorboard. I'm going to go over Tensorboard. It is very interesting to see the values, to see the results. So Tensorboard is what is going to give us this visualization. And I'm going to show it in the example. It's just 2 lines. You just call Tensorboard, you create your model, and then you tell it to just display the graphs. And here we are going to see, for example, the accuracy of the values, and we see from one epoch to the other how the accuracy is increasing. If we plot the loss should be decreasing, or else the model is not fitting. So if I check and I see that I have a loss that is decreasing and then suddenly it is increasing, it means that I have a diverging model and the model is not correct. I have to change it. So a Tensorboard is going to allow me to visualize the models, the graphs, to see histograms of the weights. I can also go within the different layers and check what is happening. Projecting embeddings to a lower dimensional space. So I'm going to see them in a graph. And I can see also the diagram of TensorFlow. And this is what we are going to see later on. Anybody has any comment before I continue? Or any question?
Guys, feel free to ask questions right now before we pass on to the next part of our session. Either in the chats or unmute yourselves and talk. Okay, I guess we can move on. If you guys have any questions, feel free to fill them in the chat, okay?
Okay, so I want to ask you for the poll results before we go into the applications.
Yes, Harwood, please share the poll results with us.
Okay, as we see, we have the results of our poll. That the question is, have you tried out Google Colab before? We see that we have 6 people that answered it, and 5 people didn't know about it, and 1 person did use it. Thank you.
Okay. So in this application, the easiest way is to go to the Colab. If you want to go write your own programs, you have to download the libraries, you have to download the softwares that we talked about last time on your own computers. So that we can work together, or at least show you how it works, I am going to use, and this is why I chose to use the Colab. I'm going to first go to the TensorFlow page and show you how to go to the Colab from this page. Let me see. Okay. So can you see a window with TensorFlow 2 Quick Start for Beginners in front of you?
Yes, doctor, go on.
Okay, so if I go and in here, it's just written in here, run in Google Colab. In here you have a program with the explanation and what it does. It's the same program that I have just talked about with the results in here. So if we go into Google Colab, in Google Colab, we can execute it ourselves and see how it works. This is the advantage. Just tell me, Alice, are you still seeing the same image, or did I change to another page?
No, you just went to the other page.
Okay, great. So in here we have the same application implemented on a Jupyter notebook, but it is done on the page itself. So what we are going to do, we either go in here and just run all of the program and just check the results, or we can go step by step and check every step what it does. So we have to go do them all, or else it might not execute correctly. So I begin by importing. It doesn't have any output, so it doesn't show me anything. And here I am downloading and defining the data set. I'm defining the model. This is the prediction. So if you see in here, this is Python. So predictions equals whatever the model. I choose the first value from xtrain and NumPy. It doesn't show me anything. We just write it below so that it gives us the output. So the output is an array of values with 10 different values. This is the outcome of our first value. If I execute in here the softmax is going to change these values into probabilities. Because if you look at them like this, you cannot understand them, you cannot interpret them. But when you look at them as probabilities, you can see in here that I don't have any of the values having a probability that is close to 1, that's 100%. I have all of them probabilities that it is 9.5%, 15%, 20%. 20% is not enough to define a value. It has to be above 90%. And the rest of them should be less than 1%. So it means that in here we have taken the first value before we have taught the machine what the values are, and it just tried the probability of any. So we look at the image, the model looked at the image and tried to guess it. So it says almost anything, just anything. So it gave a probability of, it could be, this is digit 0, 1, 2, 3, 4, 5, 6. Maybe it's 6 because it gave the 20%, but I cannot make sure that it's digit 6 because it could be also any of the other digits. So practically in here doesn't know anything. Just like a baby when you first give it the information, just doesn't know anything. And here we are going to define our loss function. And then we are going to apply our loss function for the first value, for ytrain1, using the predictions that we had. And we just get a value of 3.22. If you remember what I just said, the loss function has to be very, very low. It has to be close to 0 so that we consider that we have a correct prediction. So for predictions that are just anything, we have a large loss function. Why this is important to begin with? We begin by knowing where we start, our starting point. So this is our starting point with the loss function of 3.22. We compile our model and then we execute it. So as you see in here, it is passing the values one by one, the images one by one, and teaching the model to learn how to predict the values. So we have 1,875 images. It's passing all of them, and every time the model is going to predict, it's going to give at the beginning wrong values, and it's going to be corrected because I'm going to give it the training results, the ytrain. And once it is corrected, it's going to modify its own weight so that the next time it has a value, it gives a better prediction. So if I want to read the results, I have epoch 1/5. When it was executing, this number was increasing till it reached the end. I have the time it took for the execution, 4 seconds. I have the loss, it is 0.29. This is the average loss. We began with a loss of 3.2, so it is better. And you have an accuracy of 91%. Accuracy, it is how much I predicted my value correctly. The second epoch, I have the same times in here for each of the epochs. I have a loss that is being reduced and an accuracy that is increasing. I have as well in here, I have a loss that is continuing to decrease until a loss of 0.07 and an accuracy of 97.6%. So in here, they are expecting that we get an accuracy of around 98% because they already tested it several times. Why around 98%? Because if you go to the website and you try the same model several times, you are going to check that you are not going to get the same values at every time. Every time you are teaching the system, it could learn more or less. So you do not get exactly the same values every time, and that's normal. That's very normal. So when we evaluate, and this is a very important step, it is not enough to teach the system, and while you are teaching it, it gets correct values and good values. It is very important to evaluate. This means to test that if the system has correctly learned. If the system has correctly learned, when you pass it in the test, this means you give it all these values, you test it, but you don't tell it to correct itself. When the system was learning, every time it got a wrong value, a wrong result, it had to do what we call a back propagation to modify its weights, to modify its own internal functions. When it's doing the testing, it doesn't learn anymore. It doesn't modify the internal functions. It just tries out what happens if I give it new values that it hasn't seen before. So with new values that it hasn't seen before, we have got a loss of 0.07. That's even better than the value that we got while learning, and an accuracy of 97.7%. So this means that our system actually learned the classification, and it did not overfit, it did not memorize the values themselves. We have a risk of overfitting all the time. So if I have a small number of samples and a large number of epochs, so I'm giving it the same images all the time, it could give very good values in here, but fail to give correct values in the testing. And I repeat what I said before in a different chapter. Some people also, instead of only teaching and testing, they keep a sample for validation. What happens practically is when you are testing and teaching your own system, you are going to modify your model, then teach it and test it, and then modify it again and change your hyperparameters. Hyperparameters are the dropout, number of layers, number of values within the layer, and so on. So it's going to memorize, sometimes the model memorizes the values within this process. So if it gives good values in teaching, and it gives good values in testing, and then when you take it and apply it in real values, it fails. So they keep a little number of samples to validate at the end after you modify and test several times, to really check a second time that you have really taught your model and it did not memorize, it did not overfit. And here it's just to check that at the end we have a correct prediction. So we took 5 values from X test and we check the probability. I'm going to read them for you. These are times 10 to the power minus 8. So these are values that are very close to 0. Whereas I have in here a value that is 9.99 times 10 to the minus 1. That's 0.99. It means it's 99.99% correct. This is the probability of having this digit. I think this digit number is 7. And the second value, it has it in here. It has one value with a probability almost 1, and the rest with probabilities equal to 0. This is what we mean by a learning and probability of what we had, a 98% accuracy in the learning. I want to end with the Tensorboard to show you Tensorboard. I don't know if you are showing the link or you are still seeing the page, but I'm going to open directly the page from the slides. So in here I have Tensorboard, and I'm going to also run it in Colab. In Tensorboard, what we have in here to load the extension of Tensorboard. Then we have to execute the model just the same way that we had done in the previous page. So this is the same model. We are adding Tensorboard to it. We create our model. So in here, the system is learning. We have a value of loss of 0.21 going to 0.09 to 0.07. We have validation losses, validation accuracy. So the display in here, we have two extra values. So the loss is still decreasing to 0.05, 0.04. So now it finished the learning process. This is still a small model, and you see it takes considerable time when learning. Then we call the Tensorboard. So calling the Tensorboard uses this function, log dir logs dash fit. So the most important thing I want to show you is here you have the outputs. So you're going, the accuracy is increasing. You also have the loss that should be decreasing, or else it is not a correct model. You have the values in here. You can read them from the graph. And you also have the graph of your own model. So you can check your model itself from a graph. So in here I have a flatten, then I have the dense, I have a dropout, I have another dense. So this is a different model that I have opened. The first model we had just one flatten, dense, dropout, and dense. In here we have two that are connected to each other. So this is the model itself. So when we said in here, when I create my sequential model, I have a flatten layer, then dense, and so I have these 4 different layers, and I check in here in a graphical way what I have to verify. These are the nodes that we have, and these are the links that we have inside the model. I hope that I have showed you basically how to start with using TensorFlow and Keras models. I have finished the presentation. I know we still have very little time for questions. If you do have questions and you don't have time to answer them right now, we could also always send us emails and I can answer back. Don't worry. And I want to thank you all for your attendance of all the sessions, and I would like to welcome you anytime.
Thank you
Elsa?
so much, Doctor. Guys, before you all leave, feel free to ask questions here or email us. I will be sharing the chats right now. Survey link for the whole AI series. I would be very grateful if you all would fill this survey. It will be also sent by email. Please, if you can, also open your videos, your cameras, so that we can take a final group photo before we end the series. This was our last session. Thank you so much for attending this series. It was a pleasure for us to prepare it. Thank you so much, Doctor, for the presentations and your hard work. And I hope you all benefited from this. If you have any questions, don't hesitate.
Any questions, notes, remarks, we're always welcome. And hopefully we can meet again soon at the university.
Yes, hopefully. Okay, thank you so much, everyone. Hope to see you soon in more events. And if you have any questions, you can find us on social media and YouTube. And you have our email. Don't hesitate to contact us for anything. And if you want to suggest any future events, also feel free to do that. Make sure you take the survey, stay safe, and stay home. Keep it up, everyone. See you soon.